Hey guys, today we are continuing our 1.3 notes and we're going to talk about the distance formula today. So the distance between 2 points that aren't necessarily a horizontal or a vertical line that we can just count the values for. So in this case, we want to know the distance between points A and B, which is right here. If you think back to Algebra 1, you learned about something with a right triangle that would give you lengths of that right triangle. And that was the Pythagorean theorem. A squared plus B squared equals C squared. We're going to use that Pythagorean theorem to come up with our distance formula. So follow along with me for just a second. If I call this side down here, this side of the triangle, side A, the distance on this side A is the difference of those x values, x2 minus x1. And we say the absolute value because we always take the positive. When I come back over here to my formula, we're going to square A, which is always going to make it be positive anyway. So I'm going to put x2 minus x1, and then I'm going to square it. Plus, then my side B is going to be over here, which is the difference in that vertical distance. So y2 minus y1, and we square it. That equals c squared. We'll call this over here our side C, which happens to be our segment AB, which also gets squared. Now, we don't want AB squared, we want just AB. So to take care of finding just AB, we need to take the square root of AB. So we also have to take the square root of the other side. So then AB, all by itself, with no bar above it, is big square root x2 minus x1, quantity squared, plus y2 minus y1, quantity squared. And you'll want to write that up here, your formula for your distance. Big square root x2 minus x1, quantity squared, plus y2 minus y1, quantity squared. That's your distance formula. It's something you need to have memorized. Okay, so let's see how we can use that. So we want to know the approximate length of RT if we know the endpoints are 3, 2, and negative 4, 3. So we're just going to plug that in to our distance formula. So RT, no bar on top, equals big square root. Now remember our formula, I'm going to write out first, is x2 minus x1, quantity squared, plus y2 minus y1, quantity squared. So when I go back up here, remember we call our points x and y, so x1, y1, x2, y2. So then I'm just going to fill in the blanks. x2 is negative 4. So I'll put negative 4 minus, remember yesterday we did midpoint formula and that was a plus sign. This time we have a minus x1, which is 3. We're going to square that. Then there's a plus sign between these two, and then I take my y value. So my y2 value is 3 minus my y1 value of 2. And we square that. Okay, so now I'm going to take care of everything inside the parentheses first. So big square root still has to come down with us. So negative 4 minus 3 gives you a negative 7. And then 3 minus 2 gives you 1. So then we're going to square. Negative 7 squared is the same as saying negative 7 times negative 7, or positive 49. And then 1 squared is 1 times 1, or 1. So take care of now everything underneath the square root. So 49 plus 1 is 50. Now, it's asking for the approximate. Anytime you see that word approximate, that means we want a decimal approximation. So you need to locate the square root key on your calculator and type in the square root of 50. The square root key on most calculators, you're going to have to hit the second button, and it's usually on the x squared key. So see if you can find that kind of check mark figure. The square root of 50 is about 7.07. So that's your approximate answer. If you are feeling comfortable with this and you want to try the next one, I would pause the video right now and take a peek at this next example and try to go through it on your own. I'm going to start it up here. So distance formula again is big square root x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So then I want to know the length of GH, no bar on top. Big square root. x2 is -3 minus x1 is 5. Put the square root up there, plus sign. y2 is 6 minus -1 is our y1 value. And then put the square root up there. So then -3 minus 5 gives us a -8, and we still have our squared, plus 6 minus a -1 is +7. So then -8 squared gives you a +64. 7 squared gives you a +49. When we combine those, we get the square root of 113. And again, it asks for approximate. So take a minute and type that into your calculator. The square root of 113 gives us about 10.6. The last thing we look at is not necessarily using the distance formula, but it says find the length of the segment, then find the coordinates of the midpoint of the segment. So there are several different strategies that you can use here. We can count the spaces, we can cross off to get to the middle, we can use our formulas in a little different way. So to find the length of the segment, you can count to get the number of spaces, or we can say we know that the distance is the absolute value from one endpoint to the other endpoint. So -3 minus 6. -3 minus 6 would be -9, but we have the absolute value, so that tells us that the length is 9. And if you counted the squares there, it would, or the spaces here, it would be 9 spaces. You could also do 6 minus -3, which would give you that +9. Now to find the midpoint, again, you can cross off until you get to the middle, but we can use our midpoint formula. Remember we talked about that the midpoint formula was just averages of two numbers. So we know our two endpoints are -3 and 6. And when we average, we add the values that we have and we divide by the number of values. So -3 plus 6 would be 3, and then we divide by 2. So 3 over 2 is 1.5. So our midpoint here is 1.5. Halfway between 1 and 2. All right, guys. I will see you in class. If you have more questions, we'll go over them together. Have a great night.